Our next finalist is Xiaonan Lu, and the title is Composition and Structure Study of Nuclear Waste Glasses and Experiments and Computer Simulation.
Nuclear waste, the radioactive and toxic byproduct from making nuclear energy and weapons, is a serious health hazard, quoting John Oliver. He is really worried about the 71,000 tons of nuclear waste stored in the US. Of course, everyone should. Nuclear waste poses a serious threat to all forms of life and the environment. Good news is that there is one way to dispose liquid nuclear waste, called vitrification. In other words, make the waste into glass. This way, it reduces the waste volume and it's easier to handle as compared to liquid. Also, the raw materials for making the glass are really cheap. They are mostly sand. So now you might be wondering, I am in contact with radioactive nuclear waste on UNT campus. The answer is no. Everybody relax. What I have been doing is studying the relationship between glass composition and their properties, most importantly, chemical durability. The requirement for the waste glass are really high. They have to be stable under irradiation, high temperature, and resist corrosion for at least thousands of years. And this requirement can be different whether they were generated from making the nuclear waste, making the nuclear energy or nuclear weapon. So how I study is that I start with one simple glass composition, and I replace one chemical with another, or just simply adding another new element. So I make series of glasses, testing their thermal properties, mechanical properties, most importantly, soaking these glasses into solution, and to see how they behave under different environments. On the other hand, I also use computer simulation to generate these glasses, so that I can see how the atoms are interacting with each other. With the help of these advanced techniques, I'm able to better understanding the relationship between the glass composition and their properties. So it can help designing a waste glass according to the requirement of different disposal plans. As for now, I study about 50 different glass compositions, and I found some formulas that can lower the cost of waste glass production while improving the chemical durability and the toughness of the glass. Overall, glass is very fascinating, and there are many more to explore. And my research is just a tiny fraction of all the effort that put it on for the disposal. So the composition study is what I have been doing during my PhD, and I hope to continue working on this in the future. And thank you all for your attention.